They're saying this graph is a graph of velocity, so it's like the first derivative. Okay, that's what we're used to seeing as f prime. They're saying v is f of t, but they're talking about velocity, so that's a graph of how fast this item is changing. So when does the particle move forward? Look, all the y values are velocity values. These are positive y values, right? They didn't specify what it is. Maybe you could call this 3, 2, 1. I just made up some numbers there, but we at least know that they're positive. That's when something's moving forward, when your velocity is positive. So this is moving forward between x equals 0 and x equals 1. Those are all y values that are positive. Now it's moving backwards here because these are all negative y values. Because these are, remember, the y values are velocity values. So negative velocity means you're backing up. Positive y values over here, so that's positive velocity. So between 5 and 7, this thing is moving forward. So I'll put a union, 5 and 7. That's where it's moving forward. Okay, I guess that's it for moving forward. For moving backwards, it's where the velocity is negative. Okay, so it's negative all down here. These are negative y values, and the y values are velocity. So from 1 to 5, it's negative, and that looks like that's it. 1 to 5 is where it's moving backwards. Sorry, I always check myself. This is wrong. I should have parentheses. Okay, because at exactly 1, it's neither moving forward nor moving backwards. Okay, whatever this item is, it was moving forward, but it's slowing down, slowing down, slowing down, slowing down, stopped. It stopped moving forward, and now it's going backwards. So it should have parentheses at all these intersections, because at exactly those values, it's neither moving forward nor going backwards. Okay, where is it speeding up? So speed up, there's my symbol for it. Speeding up means our speed is changing, right? And then specifically it's increasing, our speed is increasing. So let's think about a car example here. Remember, this would be like miles per hour on the y-axis because it's velocity. Maybe this is 30 miles per hour. It went down to 20 miles per hour. Went down to 10 miles per hour. This thing is slowing down here. So speed down, slowing down. Is that one of the questions? Yeah, slowing down. It's slowing down between 0 and 1. And then right here, it's at 0 miles per hour. It's not going anywhere. Now the miles per hour negative. Here's negative 10 miles per hour. We're in reverse. Negative 20 miles per hour. It's speeding up here. It's speeding up backwards, right? So it's speeding up between negative 1 and 2, but we're going to stop at 2 because it stops speeding up and it starts going at a constant speed. So between 1 and 2 on the x-axis, this thing is speeding up backwards. Okay, so here it's constant. It's neither speeding up nor slowing down. And then here it starts to slow down because let's say this is negative 30 miles an hour. We're flooring it in reverse. Now as we follow along with the x-axis, now we're at negative 20 miles per hour, negative 10 miles per hour. This thing is slowing down between x equals 3 and x equals 5. So union 3, 5 in the interval notation. And then at exactly x equals 5, the speed is 0. The velocity is 0, so it's neither speeding up nor slowing down. Now it's 10 miles an hour, 20 miles an hour. It's speeding up between 5 and 6. And then it stops speeding up. And then it's at 10 miles per hour. Then maybe 5 miles per hour, 0 miles per hour. So here it's slowing down between 6 and 7. So we need another union between 6 and 7. This thing starts slowing down. And at 7, 8, 9, it's moving at a constant speed of 0, so it's actually not moving at all. So it's just staying put at those places, 0 miles per hour. So it's neither speeding up nor slowing down there. Okay, I think that's all of them for part A. Part B says, when is the particle's acceleration positive? Acceleration is the rate of change of your velocity, right? So you could graph a derivative of your velocity. So remember, when you graph derivatives, you're graphing the rate of change of your velocity function. So look, from this point to this point, we've gone down, right? That's a negative rate of change. And we can actually quantify it because, well, actually, no, we can't because I just made up these numbers, these hash marks up here. Okay, but we know it's at least negative. The derivative of velocity is negative here because it's going down. So at x equals 1, It's a constant decrease, right? It's going down one to the right one, down one to the right one, or something similar to that. So we don't know exactly what the derivative is, but we know it's constant. It's going down. The velocity is still going down. So it's all the same slope, so it has all the same derivative from x equals 1 to x equals 0 to x equals 2, I should say. The derivative of the velocity is negative. Remember, when you're graphing derivatives, the y-axis are your slopes. These are negative slopes. They're decreasing when you read them from left to right. And then here, between 2 and 3, the slopes are 0, right? So between 2 and 3, my graph of my derivative needs to have a slope, needs to represent slopes of 0. And it should be really open circles there. And then from 3 to 4, 3 to 5, 3 to 6, these are all positive slopes, and they're all the same. Every slope you draw here, whatever the number is, they're all the same. So from 3 to 6, they all share the same positive slope. So there's a rough idea. And from 6 to 7, the slopes are all the same. Every tangent slope you draw, it's going to have the same slope, and it's negative. So just make a guess on where that is. We can't know without having numbers for the y-axis, so this is just a guess. Okay. And then from 7 to 8, the slopes are 0. 8 to 9, the slopes are 0. From 7 to 9, the slopes are right here, 0. So that's the graph of the acceleration. When is the particle's acceleration positive? This is where it's positive on the y-axis, right? So between, what is that, 3 and 6, I think we found. Yeah, it's positive there. So between 3 and 6. So, I mean, interval, I don't know if the book's using interval notation or inequality notation, but between 3 and 6 with interval notation, that's where it's positive. Where is it negative? That's where the slopes are, the slopes of the velocity are negative. So down here and down here, that's where the acceleration is negative. So between 1 and 2, 0 and 2, I should say. And then we said between 6 and 7. That's where the acceleration was negative. And where is it 0? I'll leave that for you. That's just these locations, right? See, when does a particle move at its greatest speed? Let's see if we can figure that out from what we have. I don't know, do we really not have the y-axis? So the greatest speed, because I'm wondering about how fast it was going right here. The speed is just the absolute value of the velocity. So if you want to graph a graph of the speed, just take the absolute value of this graph here. So this is fine. The absolute value of positive numbers are positive numbers. Then the absolute value of these negative numbers are negative. I don't know if you can tell without knowing the y-axis. That plateau. So I'm just looking at it and taking the absolute value. And you can keep going. So all these negative values become positive. So if you're graphing speed, it would look something like this. I mean, my guess, this is the graph of speed. My guess is that this is when it's at its maximum speed, but I don't know how you can be sure of that without knowing those y values. It's because this is speeding up, right? It's going backwards at a faster and faster rate. So when we get down here, the graph is at its greatest speed because we're moving backwards and we've leveled off, and now we're keeping that same constant negative speed. Okay, so I think since those y values seem further away from the x-axis than these y values do, but like I said, unless you have numbers there, how can you be sure of that? Look and see what the textbook says. Maybe I'm missing something. Yeah, it says between 2 and 3 we've leveled off, right? And that's our greatest speed. But it also mentions this point. It says that's also at its greatest speed. But how do you know which one's bigger? It doesn't say. So it says x equals 0, and between x equals 2 and 3, and that makes sense because it's holding that fastest speed between those two places. We're flooring it in reverse. And I guess we've set on cruise control in reverse somehow because we're keeping the same speed in reverse. When does the particle stand still for more than an instant? So where is the velocity equal to 0 is what that question is asking. Okay, the velocity is 0 for more than an instant between 7 and 9, right? 0 miles per hour is what the y-axis is telling us. It's for an instant, it's standing still here. Where is it standing still for more than an instant? That's where the derivative is 0 for a while. So it's the velocity is 0 between 7 and 9 here.